You guessed it, we're going to do some more radical review, so think of this as your sequel lesson. We're not quite there with all we need to review before we tackle the real geometry work of this unit. There's going to be a lot of arithmetic involving square roots, and I want you guys to be solid on it. At the top of your paper, you're going to write down this perfect squares number line. Try to do this from memory, so pause the video and then come back. Actually, no, don't pause the video. How about I'll just play you a little music, cover this up, and you can write this from memory.
One is 1 square, a 2 times 2, 2 square. The base is what we multiply. The exponents of every kind square. A 4 times 4 is 16. 5 squared is 25. A 9 3 squared, 6 squared is a 36. That's right, big kind square. Baby, I don't care. Is the inverse of a square, my friend. The square root of 100 is a 10. The square root of the square is 10. 64 is 8 square. 81's 9 square. 49 is 7 square. And now that you're aware, think I'm square. Baby, I don't care. Baby, I don't care. Baby, I don't care. Baby, I don't care.
I love it. There's nothing like a little Elvis to get things rolling. Okay, here we go. So we're going to tackle in this lesson how we handle fractions when we've got square roots in them. There's a property to do it. It's called the quotient property of radicals. Let's take a look and then we'll check out these examples. What it says is if you have a square root, notice that square root goes over the whole fraction, then you are allowed to consider the numerator separate from the denominator. So you're just going to split it up into 2 different square roots, one in the numerator, one in the denominator. So on this first example, the first step I'm going to take is to change it so that it says square root of 16 separate from the square root of 49 in the denominator. Look at them as 2 separate numbers instead of just one big fraction. And then we can handle this, especially if you did your number line. Square root of 16, that just goes down to a 4. That's a nice perfect square. And wouldn't you know it, 49 is also a perfect square. That doesn't always happen. In this case it did, so we get a nice 4/7. That's our final answer. In this next example, again, I'm going to use that quotient property, and I'm going to change it to just a square root of 1 over a square root of 81. Okay, so they're split up. Now I just handle them individually. Square root of 1, it's a perfect square. That's 1. And, oh, this one's 2. 9 for that square root of 81, so that's my answer there. Now you want to reduce your fractions if you can, always. That's a standard rule, so keep that in mind. Last thing, we're going to look at a few patterns here. Let's just tackle this like we have with the last video. I've got 2 square roots. I'm going to multiply them together. So that means that I can write them as 1 square root by multiplying the 5's together. So square root of 25. And then simplifying the square root of 25, a nice perfect square, that gives me 5. I'm done. Here we have the same problem. We've got a 7. Now 7's not in the square root. I'm only going to multiply together those square roots. So it's the 8 times the 8 to give me 64. And the square root of 64, that's just 8, a perfect square. So I 56 in my final answer. Now, yeah, guys, we want to see a pattern here. There's something special going on. The fact that we did not get a square root in our answer isn't a coincidence. Why did that happen? Look back over here at these 5's. They were the same 5. It was a twin. In other words, the square root of 5 times the square root of 5 was just taking the 5's, multiplying it by itself, so we were just squaring it. So that ends up giving me a chance to cancel. The square root and the square that happened just cancel out, and it just brings the 5 right out. So what you need to know is that if you have 2 square roots that are exactly the same, you can skip a lot of steps and go straight to pulling them out of that square root. Here I've written it for you in math form. It says this. Let me erase all this out. So in math form, it says this. Identical square roots multiplied together is just the same thing as squaring that. And squaring cancels square rooting. Those guys cancel out and just bring out the a that we had, comes right out. So when you see those twin square roots, you just need to go straight to the number that's under them. Let me show you here. All right, 2 times 5. Those aren't in the square roots. They need to be brought together, multiplied. But in the square root, I see a 6 and another square root of 6. Times them together. I'm just going to call that 6 on the outside. So that's a 60. See how that works? Same goes for this one. The 2 and the 4 multiply to make the 8. Then this lovely 2213 square rooted. No idea what that is, but I do see its twin. I'm just going to write those 2 square roots, cancel out the square root, just bring out the number. It's 2213. So now we got to figure out what that multiplies out to be. Let's grab a calculator. Alrighty, punch this in. So we want 8 times 2213. And we get 17,704. What do you know? There's my favorite number. Surprise, surprise. Check it out. Here's the thing for this lesson. You must remember that if you're asked to give radicals in simplest form, number 1, and we saw this in the last lesson, no perfect square factors can be in that radical. So we want to pull out any perfect squares we can find. But second, and this is our new one, if we have fractions, no radicals in the denominator. In other words, you'll hear the directions said as rationalize the denominator. So with math and computing things, it makes it a little bit of a challenge to be dividing by a square root. It's okay to have it in the numerator and multiplying it, but dividing it makes things a little difficult. So we want to simplify and get rid of the square roots in the denominators. And this is how that works. We do a little trick, and we do this every time. If we have a square root in the denominator, we're going to multiply by its twin. In other words, we're just going to put another one in the denominator. So there's 2 of them. And so we're not changing the value. You're going to want to make sure you do the same in the numerator. So what we're really multiplying here is a creative number 1. Multiplying by 1 doesn't change the value. It's just going to change the look quite a bit. In the denominator, the trick just happened that we just saw. I have exactly the same numbers under the square roots, and they're multiplied together to just bring that 11 out. So my answer for this, down in the denominator, all I have is 11. Up in the numerator, I'm just going to multiply my 5 and radical 11 by writing them together. And it looks just like that. So, goal accomplished. There's no square roots in the denominator. And we're done. Let's look at another example. First step, I want to make sure that I split this square root into 2 separate parts. So I want to do square root of 3 over square root of 7. Then I want to make sure that I don't have square roots in denominators. So I'm going to multiply by the twin down there. Just bring another square root of 7 in. Same goes in the numerator. And what that gives me in the bottom is the 7 just gets to come out. So 7's on the denominator, and then both in square roots, let's put them together and make it say just 1 square root of 21. Now check it. Can you pull anything out of that square root? Well, you got your number line at the top. It goes 0, 1, 2, 3, and up here we got 0 times 0, 0, 1 times 1 is 1, 2 times 2 is 4, then 9, then 16, 25. So coming through here, the square root of 21 would be here. Do any of these numbers go into it? Well, we don't care about those. Nope, this is as good as it's going to get. So we have our final answer with this one. That's the simplest form. A couple more would be smart to do. Okay, so first thing I'm going to do here is I'm going to just split that up. Let's put a square root of 6 on the top and a square root of 24 downstairs. Now let's get rid of that square root in the bottom by bringing another square root of 4 in and putting it on the numerator too to keep everything the same. Okay, so these guys are twins, both under square roots. We just get to pull it out and call that call that 24. Looks like a 29, but it's a 24. Up here, both of those can multiply together. I'm going to get a square root of 6 times 24 is 144. Okay, now can I simplify the square root of 144? I can. That's a perfect square. That's 12. So I've got 12 over 24. Ooh, I can simplify that. I can reduce that fraction. I'm going to divide both parts by 12, and that's going to bring me down to 1/2. So my final answer would be 1/2 on this thing. Now before we move on, I want to show you something, and maybe a few of you saw this at the beginning. There was a different way we could have gone from the beginning that maybe would have been a little easier. Let's say that before we did anything, we simplified the fraction. Let's reduce this fraction from the beginning. So it's still under a square root, but can't I divide 6 and 24 both by something? Yeah, I can divide them both by 6. So let's reduce that down 6 goes into 6 once, and 24 divided by 6 is 4. Now let me split those square roots up. So it's square root of 1 and square root of 4. And these are nice perfect squares. That's going to be 1, and square root of 4 is 2. So I've got my final answer. To me, that was a lot easier. So here's the lesson we learned. When you start with a fraction, if you can, reduce the fraction, make it smaller or lower terms, the rest of the problem will be a lot nicer to work with. Okay, so with that in mind, I got to divide this up. Okay, with that in mind, let's do this last one, starting with the reducing. The 2 and the 8 are both under radicals. Can we bring those to smaller terms? I'm just going to carry the 3 over, but let's divide the 2 and the 8 both by 2. Let's call that square root of 1. And dividing this one by 2 gives me square root of 4. Okie doke. How about we square root the 4? That's a perfect square. So we're going to do 2 on the bottom, and 3 times the square root of 1 is just 3 times 1. That's final answer of 3 over 2. Now there is more than one way to do these. There usually is with these radical problems. Look for the easiest ways. Think about bringing things to lower terms if possible. And really, what you got to remember for the whole thing is when you have two radicals that are twins multiplied together, you got to be able to just go straight to pulling that number right out. That's the main thing, and we'll use that as we work through the rest of this chapter. Good luck on the try these.